Hey gang, welcome back to Inverted Pursuits Laboratory. Now, recently I released two videos. One was the final fight of Phoenix where it blew up mid-air, and I only recovered the fin can from it. And the second video I recently released was of my next 3D printed rocket called Chimera. It was a prototype that I rapidly printed together and scrounged together from random spare parts and bad prints I had of the Phoenix rocket, since Chimera and Phoenix are sibling rockets. And I just did a quick ejection test with it, and the whole purpose was just to try and see if I could recreate the Phoenix failure mid-flight and see if I could make the rocket blow itself apart. I was unable to do so. I think that's because I changed the design of my motor mount tube for Chimera to be different from the Phoenix ones and also include a shock cord mount, which my previous ones didn't. The previous ones had a separate piece that mounted inside, and I think that's what plugged up my rocket and caused it to blow up. That testing went beautifully, but with that, we're going to show you guys the pieces of Chimera and the entire build process I go through to get it ready for its first flight. Alright, so to start off, we're actually just going to sand everything down. So I'm taking a moment to file all the parts, and of course this video footage is sped up because taking a file and sandpaper all these parts is quite the tedious job. What I'm doing here is actually cleaning up the tip of the nose cone. The print didn't come out quite as good as I would have liked to, so I'm just taking a file to it and simply reshaping it. It's a pretty simple process to do. Just follow the lines and shape it down to the way you want it to look. From there, I'm taking the sandpaper and just roughing up all the surfaces. The goal is to remove the layer lines on all of the parts. So I'm starting with the nose cone, and then I will slowly work my way down the rocket. This is also just an initial sanding. I will later further sand it. I'm just trying to get some of the roughness off the parts initially before I get to more detailed sanding. So now we're doing a test fit of all the parts, making sure they fit the way we want them to. I'm also getting them aligned. So I have the fin can at the bottom, body section 1 is the next piece up, then body section 2 and body section 3 that the nose cone connects to. So now I'm taking my file and sandpaper and I'm going to clean up all these joints, all the places where the prints may have warped out due to contact with the build surface or just the nozzle extruding them a little weird. Now I'm taking them and I am sanding on all of the flat surfaces and cleaning them up so that the mates are a little more clean. I noticed during the filing that things weren't quite as lined up as I'd like to. So I just simply take them to a piece of sandpaper and I'm cleaning up those edges to help the mating surfaces. So now that that's all done, we're going to go ahead and glue the pieces together. I'm starting with the fin can and body section 1, so I'm adding a little bit of CA glue. These parts are printed in PETG, or PETG, depending on how you like to say it. So CA glue bonds them pretty much permanently and instantly. Since this is all just a press fit together, they just slide right on, no problem. Next, I'm doing body section 2 and body section 3, gluing them together. Now that this is all assembled, I'm actually going to take the two halves and glue them together. But in order to do that, I'm wanting to try and make sure that my rail guide locations are as aligned as possible. You can do this with a ruler. I use a scrap piece of my rail guide to give me a chance to line them up. Ruler's just as effective taped to the side of the rocket. line it up, slide it together, and it's solid. Unfortunately, there's little room for adjustment with CA glue. It pretty much instantly bonds. Here is that part where I said I was going further into sanding. I'm using orbital sander here to start, and we can see how smooth that turned out. I also took and did it with finer grit. So now we're cutting the parts for the motor mounting tube. I'm cutting 3 inches of 1mm steel wire that I picked up at my local hardware store. You can see that there. And now I'm going to go get the pliers, I forgot. And I'm going to bend this thing into a curve. There's not an exact science for what this curve should look like. I'll make a very brief flash to the camera here of what that curve is. And then I just give it a shot through the motor mount. And the curve wasn't quite enough, so we've got to adjust it again. And this time it slid through with ease. I was able to grab the other side with the pliers and just pull it straight up and out. End up with 2 pieces sticking out. Now I'm going to cross these over and actually braid them back on each other. It's very hard to see because my hands are in the way. But what I'm doing is I'm taking one side of the wire, cross it over the other, and I'm twisting it around the opposing wire and doing the same with the other, so that it ends up making a very nice arc. Now there was a little bit of pokey sticking out, poked myself, so I curved it a little bit better. And then of course I test fit into the engine to make sure it all works. And I'm now needing to steal the shock cord off my prototype I did when I was trying to figure out why Phoenix blew up. And so we actually used 3 440 screws to hold the motor mount into the rocket. It can be CA glued in. I prefer to use the screws so that I can pull them out and swap out the motor mount tubes. I've designed here a version for an 18mm motor, but I also have versions for 24 and 29mm motors. With that, the rocket's together, and we just need to tie the other end of the shock cord to our... Alright, and with that, Chimera is assembled for her first flight. So I've just got the shock cord and the rocket body here. The next thing I'll need to do is attach my parachute in. I've just got, this is a 18-inch flat sheet parachute here that I'll be attaching in. It's got a little bit of damage I need to fix before I fly it. Actually, I think that's a 20-inch flat sheet, not an 18-inch. And then the other thing to remember before you fly is if you're flying on Estes motors, this rocket does not have a back retention for it. So what you need to do is take a piece of 1-inch tape and wrap it around the base. So this is a little thick, but I'm planning to cut it off. So I always use this line, or where the lettering is, as my way of squaring myself up. And then I wrap around the engine. And what this is doing is now creating that stop that's going to keep your engine from shooting through your rocket. So now we've got a positive stop. I reach way over. We take the X-Acto knife. And you just cut the thing square. I have flown rockets dozens of times with nothing more than a little bit of tape retaining the rocket engine, and when you push it in the back, it butts up and you see the green tape holds it in place, and you can put an insane amount of force into that and it won't come out. It wrinkles the tape a little bit, but that's all the more it ever does. But all right, let's pop a parachute in her and get off to the pad. Alright gang, we're now out at the pad. So we're actually going to test fly Chimera on this Q-Jet D16-6. And so it's got a little black powder charge in there, and I've got the nozzle taped off at the moment. There's my igniter. But We're also going to be using a flyaway rail guide system. First time I'm trying one of those out. It took me a little bit to ensure that it was going to get all the way off the rail with what I assume will be no major issues, but we're starting the definition of low and slow with this D16. If this doesn't work, we'll upgrade from an 18mm motor to a 24 and keep going. Alright, well, we didn't go very far, so obviously the 18mm motor does not have enough thrust. It did successfully eject, and the rail guide component came off, so that was definitely a plus. Everything came out just like it was supposed to. I mean, we didn't fly, which isn't quite what I wanted, but we learned something. 18mm, way too small. This thing pretty much has to fly on a 24mm minimum. So we will do that in the next video. If you're interested in helping support my channel, check out my web store linked in the description below. There you'll find STL files that you can print at home for various rocket parts. Thanks for watching, gang, and I'll see you in the next video.